Expressions, Standard 1, Objective 2, Algebra 1, EOI review. We're going to look at this chart again. This lesson is going to be over number sense and algebraic operations. So Standard 1, which remember there's going to be 15 questions over Standard 1, which is 27% of your test. And then this is going to be over Objective 2, expressions. Of the 15 questions for number sense and algebraic operations, 9 of them they say 9 of them could be over expressions. When substituting a value for a variable in an expression, put the value in parentheses and then use the order of operations. Make sure you plug the value in parentheses so that you do not get confused on whether you're multiplying numbers or if it's like 48 and it should be 4 times 8, you'll get the wrong answer. Just be careful when you're plugging in these values. So if you look at the first example, it says when x equals 8, what is the value of 4x minus 1/2 x? Well, in the expression 4x minus 1/2 x, there's 2 x's, and then they've told me what they want me to substitute for x, which is 8. So all I'm going to do is keep 4 and the minus 1/2 and plug in my x's in parentheses. So I have 4 times 8 minus 1/2 times 8. Well, 4 times 8 is 32, and then half of 8 is 4. So now I just have to do 32 minus 4, which is 28. So my answer is B. These problems should not be very difficult. Sometimes they do get more difficult. I believe here in the next example they do. When you have more variables and more things to substitute, it can get a little confusing, and that's why you have to keep your work organized and make sure you're not just rushing through and make simple mistakes that could be avoidable. Absolute value, you're going to treat it like parentheses, but the value on the inside of this notation is always going to be positive. So this next example says, what is the value of the absolute value of y minus 4 when y equals negative 7? Well, just like before, we're just going to plug in negative 7 for y, but this time we have the absolute value notation, and we do need to keep that. So it's going to be the absolute value of negative 7 minus 4. For right now, we're just going to do negative 7 minus 4. That's what's inside of my absolute value notation. Negative 7 minus 4 is negative 11. But I want to take the absolute value of a negative 11, and remember the absolute value is going to turn a negative into a positive. So the absolute value of negative 11 is D, positive 11. This is the one that gets really tricky, and you have to make sure that you keep your work organized. We have, what is the value of the expression 3m minus 2 times negative n minus m times n when m equals 3 and n equals negative 2? The first step is to rewrite the exact expression like they've given it to us, but now we're going to substitute in 3 for m and negative 2 for n, putting them in parentheses each time, and so we have tons of parentheses. Now we just have to use the order of operations. Remember, the order of operations would tell us to look at parentheses first. Well, right now we have tons of parentheses. All of them are showing multiplication, though. Exponents would be next, and this problem does not have any exponents. Then we need to multiply and divide from left to right. So multiplying and dividing from left to right is going to be my next step. The first multiplication problem that I have is 3 times 3, which is 9. And then I have minus 2, and notice in these parentheses I have parenthesis negative and then parenthesis negative 2. So I'm multiplying a negative times a negative. You could think of it as a 1, a negative 1 times negative 2, which is going to give you a positive 2. And then my final multiplication problem is 3 times negative 2, which is negative 6. Now I still have some multiplication to do. 2 times 2 is 4. And then I went ahead and I did negative times a negative 6 is going to give me a positive 6. So now I have 9 minus 4, which is 5, plus 6, which is 11. So my answer is C. This next example says to multiply radicals, multiply the numbers inside the radical. Remember, the numbers inside the radical are also called radicands. In this example, we have 2 times the square root of 2 times the square root of 8 divided by the square root of 4. The first thing we want to check always when we have radicals are any of these perfect squares? Well, the square root of 2 is not going to be a whole number. Square root of 8 is not going to be a whole number, but if you look at the denominator, the square root of 4 is 2, which is awesome because we won't have to rationalize anything. So the square root of 4 is 2, so I'm going to have 2 times the square root of 16. And how I get the square root of 16 on top is I've gone ahead and I've multiplied my radicands. 2 times 8 in the numerator is going to give me the square root of 16. And then I've taken the square root of 4 on the bottom, which is 2. Well, when I have 2 square roots of 16 divided by 2, the 2's in the numerator and the denominator, because they are not in radicals, can be taken out. So I'm going to go ahead and cross those out, and I'm just left with the square root of 16, which is 4. So my answer is C. No radicals in the denominator. If you cannot simplify the radical in the denominator to get a whole number, like in the last example, the square root of 4 was 2, you're going to multiply the fraction by the denominator radical over itself. So if you look at this example, we have 3 divided by the square root of 2. What is the simplified value of this expression? We cannot have radicals in the denominator and have it, it's not considered simplified if we do. So what I'm going to do is I'm going to take 3 square roots of 2 and I'm going to multiply it by the square root of 2 over the square root of 2. The reason why this works is the square root of 2 divided by the square root of 2 is just going to be 1. And multiplying a number by 1 does not change its value. But notice when I multiply both the top and the bottom by the square root of 2, I get 3 times the square root of 2. I cannot combine my numerators or multiply 3 times 2 because 2 is a radicand and 3 is just a constant, so I cannot combine them. But when you look at the denominators, the square root of 2 times the square root of 2, both 2's are radicands, so I can multiply them to get the square root of 4. Now the square root of 4 is going to be a perfect square. The square root of 4 is 2. There's nothing that I can do in the numerator. I can't combine 3 and 2, and there's no way to simplify the square root of 2 any further. So I'm going to know that my answer here is going to be B. To add or subtract polynomials, you're going to combine like terms. Really important to remember that if you are subtracting polynomials, you're going to have to distribute the negative before you can combine like terms. And there's an example of this on the next slide. If you look at this first example, it says 2x plus 3 minus, in parentheses, 3x minus 4. What is the simplified value of this expression? Notice I'm subtracting 3x minus 4. Because I have a negative right outside of my parentheses, I need to distribute that negative to both 3x and the negative 4, which becomes 2x plus 3. Nothing changes for the first binomial, but then I'm going to have negative 3x, because a negative times a positive is a negative, plus 4, because a negative times a negative is a positive. So that's after I've distributed the negative to both terms on the inside of the parentheses. Now what I can do is I can combine like terms. 2x minus 3x is going to give me negative 1x, or just negative x, and then 3 plus 4 gives me positive 7. So my answer is B, negative x plus 7. This next example says, what is the simplified form of this expression? We have 2x plus 5y plus 7x minus y. I can combine my 2x and my positive 7x to give me a positive 9x. And I can combine my positive 5y minus the 1y will give me a positive 4y. So my answer is A. This next example says, what is the sum of these two expressions? Sum means we need to add these together. And just like with before when we were combining our like terms, that's what we're going to do to add two trinomials. Remember, like terms mean you have the same variables to the same degree. So x squareds can be combined with x squareds, x's can be combined with x's, and so on. If you look at these two trinomials, I can combine my 3x squared plus a negative 5x squared. Well, 3 plus a negative 5 is going to give me a negative 2x squared. My next like terms, I can go ahead and when you're working on problems like this, sometimes it can be useful to eliminate answer choices as you go. Because I know that my answer is going to have a negative 2x squared, I can go ahead and get rid of A and C. Next, I can combine 8x plus a negative 4x. Well, 8 plus negative 4 is going to give me a positive 4x. And then the last thing that I can combine would be a negative 10 plus a negative 2. I have same sign, so I'm going to add the numbers, keep the sign to give me a negative 12. The best answer choice here is going to be D, negative 2x squared plus 4x minus 12. To multiply binomials, use the distributive property. You can make a table, or you could use the FOIL method. For the purposes of this video, I'm just using the FOIL method because it is a whole lot faster to show you, but distributive property and table, if you're more comfortable with, feel free to do those. Most upper level classes that you get into, they will just do the FOIL method because it is so fast, so you might try to get comfortable with the FOIL method, but for the purpose of this test, honestly, just do whatever you're comfortable with because and whatever you're consistently right doing, because that's kind of, you want to get these questions correct as opposed to trying something that you're not as comfortable with. This example says, what is the area of a rectangle? Remember, to find the area of a rectangle, you multiply length times width or base times height. And in this case, both of these measures are going to be binomials. So I'm going to have to multiply 2x plus 9 times x minus 2. FOIL method, F stands for first. The first terms in each binomial are 2x times x, which is 2x squared. O stands for outer, so my outer terms would be 2x and a negative 2. Well, positive 2x times a negative 2 is a negative 4x. I stands for inner, so 9 times x is a positive 9x. And L stands for last. The last terms of the two binomials are 9 times negative 2, which is negative 18. Now I do need to combine my like terms. In the middle I have a negative 4x plus 9x, which is going to give me a positive 5x. So my answer here is B, 2x squared plus 5x minus 18. The next statement we need to talk about is if an expression has a greatest common factor, or GCF, you can go ahead and factor it out of all the terms. This example says which expression is a factored equivalent of x cubed plus y squared plus x squared times y squared. If you look at these two terms, both of them have an x and both of them have a y, so we know we can factor out both an x and a y. Now, the smallest power of x is going to be squared, and both y's are y squared. So I'm going to be able to bring out an x squared and a y squared. For the first term, I would still need another x, so I'm going to have x plus 1 as the remaining binomial. Another thing that you could do on these is you could go ahead and multiply them out and see which one. Clearly, we have an addition problem. We have a binomial here. A and B are not going to get you a binomial. They're only going to get you a monomial. And if you look at C, they've just added another y instead of adding another x, which we needed another x for my first term. This next example says to factor a trinomial in the form of x squared plus bx plus c, list factors of C that have a sum of B. Basically, this form means that you don't have a number in front of x squared. It's just going to be an understood one. And then to factor a trinomial with the form of ax squared plus bx plus c, list the factors of AC that have a sum of B. So in this case, I'm going to have a number other than 1 in front of my x squared. So it could be like 3x squared plus 2x plus 4. I don't know, I just made it up. Or something like to that effect, to where you're going to have to multiply A times C before you can list factors. This example says, which expression is the factored equivalent of 3x squared minus 4x plus 1? Notice in this case, my A is something other than 1. In this case, my A is 3. So the first thing I need to know is my AC, or 3 times 1 is 3. The B, or what the factors need to have a sum of, is going to be a negative 4. Well, think about this really quickly before you start making a table, because if you think about it before, it will be less frustrating. I need two numbers to multiply together to give me a positive 3, but have a sum that is negative. There's only two ways to get a positive number. A positive times a positive, which would clearly have a sum that is positive, or a negative times a negative is also going to be a positive, but the sum would be negative. So I know I need to list two negative factors of 3. 3 is a prime number, so this one should be really easy. The only things that multiply together, the only whole numbers that multiply together to give me 3 would be negative 1 and negative 3, or positive 1 and positive 3. We've already ruled that out though. And then the sum, negative 1 plus negative 3 is negative 4. So those would be our two factors that we need to use. Now, when we have a trinomial in the form of ax squared plus bx plus c, remember we're going to have to take the negative 4x and we're going to rewrite it as 3x squared minus 1x minus 3x plus 1. I've just rewritten the trinomial using my two factors and broken up b into two factors times x. Then I can factor by grouping. When the GCF of 3x squared minus 1x is going to be x, so x times 3x minus 1 is going to be the same thing. And then I can also group my negative 3x plus 1. Now, just looking at the binomial created 3x minus 1, I'm going to go ahead and pull out a negative 1 here, because I know that I need, inside of my parentheses, I need a positive 3x and a negative 1. Now that I have both of these binomials are 3x minus 1, I can bring out the constants in front of them and I can combine them to create another binomial. So I have x minus 1, which are the two terms that are being multiplied by the binomial 3x minus 1. So I can combine them and have x minus 1 times 3x minus 1, which is going to give me A as my answer. If you think it is easier on this one, you could FOIL all the answer choices and see which one works. A is going to be the only one that gives you the correct trinomial. So what you could have done here is you could have gone ahead and just FOILed A, B, C, and D and seen which one gives you 3x squared minus 4x plus 1. That would be another way that you could answer this question and get it correct. If there's a GCF of the trinomial, it's going to be helpful to factor it out first and then factor the remaining trinomial. So if you look at this example, it says, which expression is a factor of 4x squared plus 2x minus 2? Well, if you look at the numbers 4, 2, and 2, they clearly are going to have a GCF 2 is a factor of all of those. So what we're going to do is we're going to bring it out and we're going to say 2 times 2x plus x minus 1. All that does is factors out the GCF. Now I know my AC is going to be 2 times negative 1, which is negative 2, and my B is going to be a positive 1. So I need two factors of AC that have a sum of a positive 1. Well, two ways to get negative 2. I can do negative 1 plus 2, which has a sum of 1, or I can do positive 1 and negative 2, which has a sum of negative 1. I want to use the negative 1 and the positive 2 because I need the sum to be a positive 1. So when I do that, I'm going to break up my b, or my x, is negative x plus 2x. So I have 2 times 2x squared minus x plus 2x minus 1. When I break these up to factor, I can bring out an x of the first two terms, 2x squared minus 1, which leaves me with 2x minus 1 on the inside, and then plus 1 times 2x minus 1. Combine your x plus 1, and you get 2 times x plus 1 times 2x minus 1. If you look at your answer choices, the only factor that is a choice is x plus 1b.